Today we have to start with a new chapter, coordination chemistry. Coordination compounds are a class of addition compounds. So, before studying about coordination compounds, you should understand what an addition compound. Addition compound, as indicated by its name, it is a compound formed by the combination of two or more stable compounds in their stoichiometric proportion, or they can be prepared by mixing two or more stable compounds in stoichiometric proportion and allowed to stand for a long time so that they can crystallize to form addition compounds. If two or more stable compounds are mixed and allowed to stand for some time, they will definitely form addition compound. They can be classified as double salt and coordination compound. How they can be distinguished or how they differ from each other. Both double salts and coordination compounds are stable in solid state, but in solution there is a markable difference between the two. What difference they have? At first, you have to see how how addition compounds can be formed. FeSO4 is a stable compound which has independent existence. Ammonium sulfate is another stable compound which has its own stability and existence. When ferrous sulfate and ammonium sulfate mixed in 1:1 ratio, because their coefficients are 1 and 1, 1:1 ratio in aqueous medium, they will form a salt FeSO4, NH4 twice SO4, 6H2, that is more salt. It is an addition compound formed from the ferrous sulfate and ammonium sulfate. Similarly, other two stable compounds of potassium sulfate and aluminum sulfate can be dissolved in water, and on standing they will crystallize out as potash alum, K2SO4 dot Al2SO4 thrice 24 H2. Third one, copper sulfate, a stable compound, react with another stable compound of ammonia in the ratio 1:4 to form CuSO4 4NH3. This actually we have tried CuNH3 4 times SO4. This is the actual representation. And FeCN twice plus 4KCN in the ratio 1:4. They also gives K4FeCN6, potassium ferrocyanide. These four compounds, this one, and this one, all the four compounds are addition compounds and they are stable too. But when they are dissolved in water, double salts, when dissolved in water, completely ionizes to form individual ions. They do not retain their identity in aqueous solution. They completely undergo dissociation. While coordination compounds retain their identity in solution. Example, first addition compound was FeSO4 NH4 twice SO4 6H2. which when dissolved in water form Fe2 plus, NH4 plus and SO4 2 minus. They undergo complete dissociation to ions. At the same time, a compound like K4FeCN6 that was there, K4FeCN6, when dissolved in water form 4K plus and FeCN6 3 minus. So this kind of compounds, double salts, undergo complete dissociation in aqueous solution. But coordination compounds, this kind of compounds, they are called coordination compounds, retain their identity in aqueous solution. They do not undergo complete ionization. They can retain their identity in aqueous solution. Only the counter ions are ionized. The remaining part is stable in aqueous solution. This kind of compounds are called coordination compound, and in this chapter we have to deal with coordination compounds, not with double salts. Now that discussion is over. Now we have neutral complex. They do not have any charge and do not undergo ionization in solution. Such complexes, when dissolved in water, they have no capacity to ionize in water. They are highly stable also. Example, NiCO 4 times. This is a neutral complex because it does not have any charge and it is insoluble in, it do not undergo dissociation in water. At the same time, complex ion, this is neutral. Complex ion, it may be cationic or anionic. They have charge and they undergo dissociation in water. Complex ion is an electrically charged species in which a neutral atom or ion is linked to neutral or charged ions through coordinate bond. CO3 plus, a charged ion, when combined with neutral molecules ammonia, we will get a charged complex. In the same way, Fe3 plus ion, when combined with 6Cn minus ligands, we will get this complex. These are anionic, this is cationic. Since it is positively charged and it is negatively charged. Now we are coming to important terms in coordination chemistry. These terms you have studied in your plus 2 classes also. The first term is coordination entity. Coordination entity. An ion or molecule containing a central metal atom or ion bonded beyond its normal valency with charged or neutral molecules through coordinate bond. Coordination entity means ഒരു ആറ്റം അല്ലെങ്കിൽ അയൺ ചാർജ് ഉള്ളതോ ഇല്ലാത്തതോ ആയ മോളിക്യൂളുമായി കോർഡിനേറ്റ് ബോണ്ടിലൂടെ കമ്പൈൻ ചെയ്യുമ്പോൾ ഫോം ചെയ്യുന്ന അയോൺസാണ് അല്ലെങ്കിൽ മോളിക്യൂൾസാണ്. ഇറ്റ് മേ ബി അയോണിക് ഓർ ന്യൂട്രൽ. ഇൻ ദിസ് എക്സാമ്പിൾ CO3 plus ion, metal ion, combine with neutral molecule of ammonia to form a complex. Coordination entity. Here atom, not ion, nickel atom, combine with neutral molecule carbon monoxide to form this complex. Here Pt2 plus ion combine with 4Cl minus ion, they are charged, Cl minus is charged to form the coordination entity like this. So coordination entity is formed by the combination of an atom or metal ion through their combination with certain molecules or ions using coordinate bond. Second one is central metal atom or ion. Actually, in a coordination complex, we should have two entities. One it is metal and other is ligand. Those who can accept lone pair from ligands is called central metal atom or ion. An atom or ion capable of accepting lone pairs from ligands so that a coordinate bond can be formed between them. So we have two options, either it may be atom or ion. Whatever may be it, they have the capacity to form coordinate bond with ligands. The peculiarity of ligand is that they are capable to donate lone pairs, or simply we can say that ligands are Lewis bases and central metal atom or ion is Lewis acid. Lewis base always donate lone pair to Lewis acids and coordinate bond established between the ligand and metal ion. Third one is ligand. Ligand is a wide topic which we can detail in another video. Simply, they are ions or molecules which can donate lone pair to central metal atom or central metal ion. Any species which can donate lone pair to central metal atom or ion. They can be anionic like Cl minus, OH minus, Br minus, CO3 2 minus, etc. They can be neutral like CO, NO, NH3, etc. These ligands can be cationic also, NH2, NH3 plus or NO plus, like that. What is density? That is other technical term which you have to familiarize. Density. Number of lone pairs donated by a single ligand is called density of that ligand. ഒരു ലിഗാൻഡ് വരുന്നത് എന്തിനാണ്? ലോൺ പെയർ കൊടുക്കാനാണ്. ആർക്ക് കൊടുക്കാൻ? സെൻട്രൽ മെറ്റലാറ്റത്തിന് കൊടുക്കാൻ. സെൻട്രൽ മെറ്റലാറ്റത്തിലേക്ക് ലോൺ പെയർ ലിഗാൻഡ് കൊടുക്കുമ്പോൾ ഒരു കോർഡിനേറ്റ് ബോണ്ട് ഉണ്ടാവും. അല്ലെങ്കിൽ ലിഗാൻഡ് സെൻട്രൽ മെറ്റൽ ആറ്റത്തിൽ ഒന്ന് കടിച്ചു എന്ന് വിചാരിക്കും. ഡെൻസിറ്റി, അത് പല്ലുമായി ബന്ധമുള്ളതാണ് ഡെൻസിറ്റി എന്ന് പറഞ്ഞാൽ. അപ്പോൾ ലിഗാൻഡ് സെൻട്രൽ മെറ്റൽ ആറ്റത്തിൽ എത്ര സ്ഥലത്ത് കടിക്കുന്നു, എത്ര സ്ഥലത്ത് ബൈൻഡ് ചെയ്യുന്നു, അല്ലെങ്കിൽ എത്ര ബോണ്ട് ഉണ്ടാക്കുന്നു, എത്ര കോർഡിനേറ്റ് ബോണ്ട് ഉണ്ടാക്കുന്നു, അതാണ് അയാളുടെ ഡെൻസിറ്റി. ഒരു ലോൺ പെയർ കൊടുക്കുന്ന ആൾക്കാരാണെങ്കിൽ ഒരു ബോണ്ടേ കാണും. അതുകൊണ്ട് ദേ ആർ മോണോഡെൻഡേറ്റ്. രണ്ട് കൊടുത്താൽ ബൈഡെൻഡേറ്റ്. അത് പിന്നെ ഡീറ്റെയിൽ ആയിട്ട് പിന്നീട് വരുന്നുണ്ട്. Cl minus, OH minus, etc. are monodendate ligands since they can donate only one lone pair at a time. At the same time, NH2, CH2, CH2, NH2. Here, this nitrogen can donate lone pair. This nitrogen also can donate lone pair. So, they can donate two lone pairs at the same time. So, they are bidentate. Next one is coordination number. Number of lone pairs accepted by the central metal atom or ion. Number of lone pairs accepted by the central metal atom or ion. So, density is the term related to ligand. How much lone pairs can be donated by a ligand? That is density. But coordination number is connected with central metal atom. how many lone pairs can be accepted by the central metal? How many lone pairs can be accepted from the how many lone pairs can be accepted by the central metal atom from the ligands? It can be from same kind of ligand or different kind of ligand. Coordination number actually number of ligands into density. Example, Fe F6 3 minus. This is central metal ion, that is Fe3 plus, and ligand is F minus. We have 6 F minus ions, so density of Fe3 plus is 6. CO C2O4 thrice. CONH3 4 times C2O4. This is oxalate. Ammonia is a monodentate ligand. So 4 into number of ligand means 4 into density means 1. They are monodentate. Ammonia is monodentate. Plus how many oxalate we have? Only one oxalate, but its density is 2. It is a bidentate ligand. So 4 plus 2 again 6. So coordination number of cobalt is 6. Here iron is 6. Now coordination sphere and ionization sphere. Central metal atom along with its ligands can be written inside a square bracket. That is called coordination sphere. Species outside the coordination sphere is called ionization sphere or counter ion. Ionization sphere or counter ion. K for Fe CN6. Okay. Here central metal atom or ion Fe and ligand cyanide written in a square bracket. So this part is called coordination sphere. K4 is outside the coordination sphere, that is called counter ion or ionization sphere. CrNH3 6 times Cl3. Here this square bracket containing chromium and ligands ammonia called coordination sphere, and Cl3 or 3Cl minus is counter ion or ionization sphere. What is ionization sphere? That is the ion produced through the ionization of the complex in aqueous solution. When potassium ferrocyanide is dissolved in water, we will get K4 or 4K plus FeCN6 4 minus. When dissolved in water, this compound gives CrNH3 6 times 3 plus and 3Cl minus. So Cl minus is counter ion. Coordination polyhedron is the spatial arrangement of ligand atoms which are directly bonded to central metal atom. ഒരു സെൻട്രൽ മെറ്റൽ ആറ്റത്തിന് ചുറ്റും ലിഗാൻഡുകളെ എങ്ങനെ അറേഞ്ച് ചെയ്യുന്നു, അല്ലെങ്കിൽ മെറ്റലിനോട് ബോണ്ട് ചെയ്യുന്ന ലിഗാൻഡ് ആറ്റങ്ങളെ എങ്ങനെ അറേഞ്ച് ചെയ്യുന്നു എന്നുള്ളതാണ്. OH is a ligand, but metal bonded to oxygen, not hydrogen. So the spatial arrangement of ligand atoms around central metal atom or ion is called polyhedron. If number of ligand is 4, they can be arranged like this, then we are calling it as tetrahedral. Otherwise we can arrange like this, so it is called a square planar. If it is 5, you will get M, L1, L2, L3, L, L, here 1 L, here 1 L, triangle bipyramidal. If ligands is 6, you will get M, 4 ligands in the plane, one at the top, one at the bottom. Then we will get octahedral. This kind of many polyhedras are possible in coordination compounds. Now oxidation number of central metal atom or ion. It is the formal charge on the central atom in a complex after the removal of all ligands with their electron pair that they have shared with atom. Ligand സെൻട്രൽ മെറ്റലുമായിട്ട് ഷെയർ ചെയ്തിരുന്ന ലോൺ പെയറിനെയും കൊണ്ട് പുറത്തു പോയാൽ ബാക്കി എന്ത് ചാർജാണോ സെൻട്രൽ മെറ്റലോണിന് മുകളിൽ ഉണ്ടാവുന്നത് ആ ചാർജിൻ്റെ പേരാണ് ഓക്സിഡേഷൻ നമ്പർ. Again K4 Fe CN6. What is the oxidation number of Fe? Potassium charge is +1, so 4 into +1 plus I don't know what is oxidation number of ion plus 6 into Cn minus charge -1, so 4 plus Fe minus 6 equal to 0, so Fe equal to +2. This is the oxidation number of ion. NiCO 4 times. We have to find the oxidation number of nickel. Nickel plus 4CO equal to 0 because it is a neutral molecule. Here we have no charge, so we have to equate with 0. Ni plus 4 into CO is a neutral ligand, no charge. 4 into 0 equal to 0, so nickel is also in 0. In this way you can find out the oxidation number, and this method you have already studied in previous classes, in lower classes. Next one is homoleptic and heteroleptic complexes. Homoleptic and heteroleptic complexes. Homoleptic means same kind of ligands, only one kind of ligand in the complex. CONH3 6 times 3 plus. Here you have only ammonia, only ammonia. It is homoleptic. NiCO 4 times. Here you have only carbon monoxide or carbonyl group, so it is homoleptic. Only one kind of ligand. At the same time, if you write CONH3 thrice Cl3, here you have two kinds of ligands. One is ammonia, another is chloride. So it is heteroleptic ligand. Different kinds of ligand or more than one type of ligand. Such complexes are called heteroleptic ligands. With this, we are coming to the end of this section, which mainly focus on important terminologies in coordination compounds. Thank you.